So this lesson is going to be a basic introduction into what we call redox reactions. And in order to do redox reactions, we first have to look at oxidation numbers. And an oxidation number is the total number of electrons that are lost or gained by an element in the process of forming a compound. The oxidation number can be the charge. For example, magnesium. We know that magnesium is a 2+. It has an oxidation of a 2+, but we also say it's the charge. But the reality is that's not accurate. Oxidation number and charge, we sort of have been using them interchangeably, but they're really not the same thing. All right, so for example, if we look at sulfate, all right, the charge of sulfate is 2-. The oxidation number for oxygen is a -2, and sulfur is a +6. So the charge of the ion is a -2, but the oxidation number is not the same thing. So we need to make sure that we are able to assign oxidation numbers correctly. All right, so I'm going to give us some rules for assigning oxidation numbers, and then we're going to see if we can't make sense of this. All right, so neutral substances, we're going to give a 0. All right, and a neutral substance, an example would be something that has one element. It would help if I could spell element. Ooh. Okay. For example, aluminum. And our 7 diatomic elements. Okay. And we are going to make these 0. So I'm going to put a little line through that so that you can tell that it's the number 0 and not the letter. Hydrogen is going to be a +1 when combined with a more electronegative element. All right, for example, CH4. And we've already looked at electronegativity. We've looked at the general trends. Okay, electronegativity tends to decrease as you move down the periodic table, increase as you move across. This is how we're going to know whether it is more electronegative or less electronegative because of the proximity on the periodic table, and that was from last unit. Go back and review that information if you need to, my friends. All right. Hydrogen will be given a -1 when combined with a less electronegative element. All right, for example, LiH. Okay. Oxygen. Let me write it out. All right. O for oxygen. It is usually a -2. All right. The exception to this would be, if you'll think back to your element and ions from your summer assignment, peroxide. All right. That would be your exception. And this is going to be an example, hydrogen peroxide, H2O2, where in this case, peroxide is now a -1 and not a -2. The sum of a neutral compound, it needs to equal 0 because it is a neutral compound. The sum of a polyatomic ion needs to be the overall charge of the ion. And finally, the less electronegative element will get the positive oxidation. For example, SO2, sulfur dioxide. All right, real quickly, which one of these is less electronegative? Electronegativity decreases as we move down. It increases as I move across. Sulfur is below oxygen, therefore it is less electronegative. Oxygen is more electronegative. Oxygen is usually a -2. So that is going to make sulfur a +4. And I'm going to show us how we get these values, okay? So up to this point, I kind of have made some assumptions that you know where these numbers are coming from, okay? I did the same thing with sulfate. So let's figure out and let's learn where those numbers come from now that we have our rules, all right? So now that we have our rules, let's look and let's figure out where those numbers are coming from. All right, let's look at our first problem here. H2 plus O2 yields H2O. Anytime you have an element by itself or a diatomic element, we are going to make those 0. Now, oxygen, we said, is usually a 2 minus, unless it's a peroxide. It is not a peroxide in this case. So there's one oxygen times a -2. Don't worry about the balanced part, do just the compound. So 1 times 2 is a -2. This is a neutral compound, so I need it to equal 0. I have 2 hydrogens, so what times 2 gives me a +2? Because I need this to overall be a +2, right? Because a +2 and a -2 is 0. So what times 2 is 2? And that's a 1. So each hydrogen is a +1. So let's come over here and let's assign oxidation numbers. And in this case, they've already been given to us for the ion part because we've been provided the net ionic equation. But we do know that aluminum and iron are both going to be 0 because they are by themselves. So take a minute and let's pause this video. This is your redox half reactions worksheet. So pause this video, try to assign oxidation numbers for 3 and 4. Okay, let's assign oxidation numbers. All right, the oxidation number has already been shown to you in the net ionic equation. Iron is a metal by itself. Zinc is by itself, so it is a 0. And finally, copper and silver are both 0s. Now, this one's a little tricky. First, you have to do nitrate by itself. This is NO3 minus. All right? So the overall charge needs to add up to a -1. So if oxygen is a -2, oxygen is usually a -2, except in its peroxide form. This is not a peroxide. I have 3 oxygens. So that is an overall -6. I need this to equal -1. So that means nitrogen must be a +5 because +5 and -6 is a -1. How many nitrogens do I have? 1. So what times 1 is 5? 5. So nitrogen is a +5. Now that we know nitrate is a -1, silver has to be a +1, and that makes sense because from our element and ions, we did learn silver is a +1. All right, so coming over here to our copper nitrate. All right, don't worry so much about this 2 right now. Just do the nitrate itself. Again, let's do it again. Oxygen is a -2. There are 3 oxygens for an overall -6. This is an ion at a -1 charge, so I need to add my oxidation numbers need to add up to a -1. So nitrogen still has to be a 5. I have 1 nitrogen, so what times 1 is 5, and that is a 5. Now I have 2 nitrates, so I have a -2 overall. So if copper, to make this a neutral compound, has to be a +2, because a +2 and an overall -2 make me neutral. So here is my oxidation numbers. And now why is this important? And this is going to be super important because of what we call a redox reaction. Okay, and a redox reaction is one that occurs because of an electron transfer. Okay. We have oil rig. This is how I like to remember it, oil rig. Oxidation is loss. And when we say loss, we mean of electrons. Reduction is gain. So we gain electrons. So oil rig, oxidation is loss, reduction is gain. So we are losing and gaining electrons, all right, within this reaction. You may also see it as Leo says GER. Okay. Gain of electrons is reduction. Loss of electrons is oxidation. All right, so if you like Leo says grrr, you can use that one. I learned it with oil rig, so it's the one that just sticks out into my head the most. All right, so that's what I use. Quite frankly, I really don't care which one you choose. So here we go. Hydrogen goes from a 0 to a +1. Oxygen goes from a 0 to a -2. So if I become more positive, I have lost electrons because electrons are negatively charged. How many electrons have I lost? I went from 0 to +1, 1 electron. If I go from 0 to -2, if I become more negative, that means I have gained electrons. And how many electrons have I gained here? 0 to -2, that's going to be 2 electrons. All right, so if oil rig, oxidation is loss, which one is losing electrons? That is the hydrogen. So the hydrogen is my oxidation. All right, so to write my half reaction here for my redox reaction, my oxidation is going to be the hydrogen, and my reduction is going to be the oxygen, because the oxygen is gaining electrons, right? Oil rig, where reduction is gain. And we have already determined here that oxygen is gaining electrons. So let's write our oxidation half reaction. What am I forming here? I have hydrogen, and it is forming two hydrogen ions that are both a +1, and one electron is being lost. Now, I have to balance this, okay? So for every one hydrogen to one hydrogen ion, because my hydrogens themselves are balanced, it's a 2 to 2. So if I reduce that down, 1 to 1 is 1 electron. So in order to balance this, since I have 2 hydrogens, I need to make that 2 electrons. Now, oxygen is being reduced, we said. It is gaining 2 electrons. So gaining electrons is a reactant. And what am I forming here? I am forming oxygen in the ion form, O2 minus. And if I balance this bad boy out, I have 2 oxygens on the left. So I need to put a 2 on the right, which is going to then change my electrons from 2 to 4 electrons. All right, let's try number 2. Aluminum, iron. All right, so aluminum is going from a 0 to a +3, so that means it has lost 3 electrons. Iron is going from a positive to 0. That means it has gained 2 electrons, because a positive 2 and 2 negatives does equal 0. So what is my half reaction here? All right, my half reaction, if I lose oil, that's oxidation. So I have my aluminum, and it is forming an aluminum ion, and it is losing 3 electrons. My iron, 2, gains 2 electrons. So gaining electrons is a reactant, losing is a product, and that is going to form Fe, that solid iron. So what I'd like for you to do is I'd like for you to pause this video, and I would like for you to try and do number 4. It's a little bit more tricky, but see if you can't solve it, and then we'll come back and we'll do it together. All right, so let's look at number 4. What is changing and what is not changing? Nitrogen is not changing. Oxygen is not changing. What is changing here? And that is the copper and the silver. Copper is becoming more positive. It goes from a 0 to a 2 plus, so it loses 2 electrons. Silver gets more negative. It goes from a positive to 0, so it has gained 1 electron. All right, so my half reaction here, copper is the oxidation, it's losing. I am going from copper to Cu2 plus 2 electrons. And silver is my reduction. I am going from a silver plus the electron it gains to form solid silver. Now, this leads us to one more thing on our important to know. Well, actually, we have an additional thing after this, okay? We have our next to last thing on our important to know sheet that we started. So if you'll pull that out, pause this video if you need to. All right, if you'll remember back when we did our synthesis reaction, and I told you on one of them, I said, you know, this isn't really the truth, and we're going to clarify the truth later on. So here we go. Let's clarify the truth. Anytime we have a nitrogen with an oxygen, and this X just simply means whatever the subscript is, 1, 2, 3, 4, 5. with water. Okay? We know from our reference tables, a non-metal oxide plus water forms an acid. So this is a non-metal oxide and water, so it is going to form an acid. If it is the nitrogen and an oxygen, this will always form either nitrous acid or nitric acid. So these are our two options. To determine which one we're going to choose, we have to first find the oxidation number. And you're going to find the oxidation number of the nitrogen. The nitrogen is what's important here. And you're going to choose the one in which the oxidation number stays the same. Okay? One additional thing, and this is the last one, and this is the remaining one on our important to know. All right. Now that we know what redox reactions are, single replacement, decomp or decomposition, synthesis type A, and synthesis type A, if you remember, synthesis type A is the formation of a binary compound. Are redox reactions. And this is going to be important, especially when we get to actual AP questions on this. All right, you may see a multiple choice where it says, which of the following is a redox reaction? Well, in that case, that's going to be really simple. You're just going to look and you're going to find the one that is either a single replacement, a decomposition, or a synthesis type A, and that'll give you the answer. So by knowing this, you can save yourself a lot of time on some of those multiple choice questions on the AP exam.